Alright, so I have got two questions coming from the improper integrals. And how do we evaluate improper integrals? Well, as you can see from these two questions, you might be able to see that, well, the limits are not allowing us to evaluate these integrals. Because here's the thing, if I try to put infinity here, after integrating, it won't work out. Even for b, if I integrate then I put 0 later on, it won't work out. So what do? If the limits are you are having infinity in it, what you have to do is that you need to transform this to another limit which you can easily work out, and let that same new limit approach the limit that you removed in the first place. So what am I trying to say here? Okay, what I'm trying to say here is, if I get for a, all right, if I get for a from 1 to infinity, then 1 over x squared dx, this is how it is exactly. So we know the graph of 1 over x squared, right? It is like this, all right, and the area, let's say starting from 1 there all the way to infinity, it's going all the way to infinity. This is the area below the curve. This is y, this is x, and this is the graph of x squared, like that. So as you can see here, all right, it's going up to infinity. So exactly the area is not making sense. You can't find the area. Is it making sense? So we need to have a closed system where we can find the area specifically. So what do we do in this case? Here's what we do. We are going to change this one to a new limit. So we can say let that limit be a. That will be from 1 to a. Okay, let me do this. We are going to have the integral from 1 to a of 1 over x squared dx. Then we're going to take the limit, like the normal limit. The limit as a approaches the one that we removed here, infinity, like that. Then we can now integrate this one. So integrating 1 over x squared, I think by now it shouldn't be a problem. We're going to have the limit as a approaches infinity. Integrating this one, we end up having negative 1 over x 1 to a, which will give us the limit as a approaches infinity. We replace there, we end up having negative 1 over a plus 1. You must be able to replace inside, right? So now this will give us the limit of a approaching infinity for 1 minus 1 over a. Then now where there is a, we substitute infinity. This will give us 1 minus 1 over infinity. Now know that infinity is a bigger number, so as we divide a bigger number into a smaller number, that number will keep on approaching 0. So we just end up having 1 minus 0, which will give us 1 as the answer. So that's the answer for that question. The same applies for b. Okay, the same applies for b. We have 0 there, 9 there, 1 over the root of x, then we have dx. We are going to integrate this from a limit. Let's say 0 cannot work out, so let's have 9 there. Then let us have a here. So for the same guy here, dx, then I'm going to take the limit as a approaches what is 0, the one that we've removed there, because if you try to plug in, it won't work out. You know that, right? So now what happens when you integrate this? What do you get when you integrate this? So after integrating, you end up having 2 like that, the power half. Then you have a here, then we've got 9 there. this will give us, so we have the first part, there's 9 there, so we are substituting 9 there. In short, we are just having 2 and the square root of 9 minus 2 and the square root of what? A. Like that. I have x to the power half, the same as the square root of A and the square root of 9 respectively. So we have limit as A approaches 0. Okay, this one will give us 6 minus 2 root of what? A. Now, all right, this is where I want you to pay particular attention. If I try to put 0 here, all right, I'll end up having if I substitute 0 there, I'll end up having 6 minus 2 root 0, which will be 6 minus 0 and give me what? 6 as the answer. So this is how you work out improper integrals, and I hope that you enjoyed the video. Cheers.